Hey everyone, it's Tim, back here again with another Web3 video. This time though, we're not going to be dealing with like JavaScript Web3. We're actually going to be deploying a smart contract. We're going to be deploying on testnet, but we're also going to deploy on mainnet almost. Like I don't have a contract that I need to deploy right now, but I can tell you with 100% certainty that this method will work. Just so everybody's aware, okay? I'm gonna click on my desktop and show you. It is October 22nd, 2021. You may be thinking, oh, why is he telling me the date? I know what date it is. No. Listen, when I started learning smart contracts, right? When I got into this, the ecosystem and tools that existed were so different than what they are now. And I can guarantee that in a couple months' time, which is about 3 years in the crypto universe, this information could be outdated. Now, is it worth watching this video in a couple months, in a couple years? Almost certainly, because there's going to be some, key pieces of information here that still will be useful. But what we're going to be doing today is we're going to be actually working on smart contracts. I'll be making another Web3 videos in the future, but for now, we're going to be focusing on smart contracts because when I started out, all I could find was information that was outdated, old, or complete overkill for what I was trying to do. Today, we're going to do something really simple, and it's like I'm going to keep it as brief as possible and make some very simple explanations that may gloss over a couple things, but for the most part, you're going to be able to deploy a smart contract, and that's it. And you'll be done. And look at that. And you'll be able to write in Solidity and actually make something, because trying to consume all of this information from Medium articles or other YouTube videos, you never know which way it's going to go. So I implore you to watch this video, watch others before you get started, just so you know what you're getting into. But this video should be a good starting point for a beginner. So what is Solidity? So Solidity is the programming language that is used for the Ethereum virtual machine, which is basically the Ethereum network, right? You can run essentially these custom programs on the blockchain. Now, one thing to know if you don't know anything about the EVM or Solidity or how any of all this stuff works. With smart contracts, there are two things you can do, right? You can write data to them and you can read data from them. Reading is free. Writing costs money because when you send data to the blockchain, you have to add stuff to it. That costs like computation power from all the nodes on the network to confirm the change and make sure there's a consensus. So you have to pay a thing called gas, which if you've been using Ethereum, you are already probably well aware of gas. Most other blockchains have this fee. Ethereum has one that right now at this time can be a little expensive. Just up front, so you know, any smart contract that you mint that you want to put a whole new program onto the blockchain that other people can interact with, or maybe just you can interact with, it's going to cost you at this time, since it's October 22nd, Ethereum I think is around $4,000 at the time of this video, that it's probably going to cost you around a cool $200 USD. I know, that surprised me too, but don't worry, there is a way to test your contract and have it on a test network to at least have it somewhere on the blockchain, right? So let's just get started because there's so much to go over. Today, specifically, we're going to be focusing on the ERC721 kind of token smart contract. So ERC721. This is essentially how your NFTs are made, right? If we were to go to a popular NFT marketplace like OpenSea, okay, you can see that, there are images here. People either upload them or they create custom ones. So like, for example, let's go look at my profile, right? This little dude, this is an ERC721 token, but what it actually is it shows that I own a token for like these mechas, right? Like I have two mecha tokens and they both have a token ID, 6728 and 6727. I own those tokens, but this image that's associated with those tokens is actually not stored on the blockchain at all. It's either stored in one of two places: on a centralized server, like you would be familiar with, right? Which would be like an API dot, something.com/whatever, right? And it would resolve an image URL that OpenSea shows you. Or it is stored on a thing called IPFS, which stands for Interplanetary File Storage, which is a fancy name for a distributed file system. Think like LimeWire, but bigger than that, if that reference doesn't date me too much. So basically what we have here is we have a fancy way of showing images for tokens that I have either created or I have got from somewhere else. So for example, a token I can talk a lot about are these solar portals. This is actually an ERC721 contract I deployed. And actually I can show you what that looks like and how this whole API plus token system works. So most contracts, most ERC721 contracts are actually hosted offsite. So the token itself very much is on the blockchain and you very much own that token. But the image itself that it is associated with, 9 times out of 10 is probably not actually minted inside the blockchain. Like that data is not in the blockchain. The file location and the URL that points to that image is, but that's it. So let's just get into it, because when someone first told me that, it didn't quite make sense to me. It's actually way less complicated than you think. So let's just start off by looking at some tools that'll help you get started. Now you can very much do all blockchain development on your local machine, like not on the internet, not in a browser, not anything, right? But the easiest way to really get started is to go to a site called remix.ethereum.org. This is a site that's actually run by the Ethereum core development team, and it is an amazing tool, and it allows you to mint contracts directly from the browser as long as you have a browser wallet installed. Today, we've got MetaMask. So we're not going to be deploying to mainnet, so that doesn't matter. But what we will be doing is we will be deploying in the virtual machine that exists in this whole ecosystem, and then maybe on Rinkeby, which is a test network. So let's just get started with, what does the most basic ERC721 token look like? And actually, you'd be happy to know that there is a third-party well, not a third party, but it is another development group or a group of developers called Open Zeppelin. They are awesome. We stand on the shoulders of some really smart people, luckily. And like they even have right here, constructing an ERC721 token contract, right? And they just import like you would import in any language, like JavaScript or Java or Python or whatever language you use, guaranteed there's an import structure. So what we're going to be doing here is we're just going to pretty much use what is essentially NPM or a version of it, right? To import some like actual like GitHub like .sol files, which is a Solidity file. So it'd be like no different than, NPM installing a different dependency. And what we have here is a contract called game item. And this just says it's an ERC721 URI storage. We'll get into some other complications with this. And essentially what it is we're going to make an ERC721 token that has a name of game item and has a kind of a ticker symbol of ITM. And there's going to be one big function called award item. Now, this is not a function that has to exist. We could rename this function to literally anything we want, and also just make a whole bunch of extensions here. This is all well and good because ERC721 essentially is a standard for what functions should exist in a contract, to where if I'm OpenSea or if I run my own like marketplace and someone says, hey, here's a contract and it's ERC721, I don't care what they did on their contract. I know that a specific some specific functions will exist, and I can just use those. If they have custom functions, that's fine, but I'm not going to interface with those. All I'm going to do is interface with the bare bones ones. And for the most part, the only things that people really interface with is the base token URI, which is basically what is the URL that I should get metadata information from. And then, what's the token name, who owns this contract, who owns a specific token, how many tokens are left, that kind of stuff. So this is a very, 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 very basic ERC721 contract. If we hop back into Remix, actually, and we can open up a brand new workspace, and we'll just call this, basic ERC721. Click OK. So you'll see that our workspace has been updated with 3 folders. So we've got a README, a test, scripts, and contracts. We will not be talking about scripts and tests today, although they're kind of self-explanatory. So scripts is actually some JavaScript functions that will actually deploy your contract. So that's always really cool. The other thing is test, because once you mint this contract, you can't modify the code. So it's really, really important that you write really good tests for very critical contracts, right? If you have a contract and you really don't want to be messing it up and you don't want to cost people money or have something, have a huge vulnerability that you weren't aware of, you need to write good tests. Sorry, but it's just a fact of life. I know some people really don't like writing tests. I kind of like it because it's a way for you to break your own program before somebody else does it and, ruins everything. So they give us 3 contracts to start out with. We are not going to be talking about these contracts, so let's just delete those. What we'll go into here and we'll just do basic contract, SOL, and we're just going to paste in this stuff. Okay, this is exactly the code from the OpenZeppelin docs. Now, there's probably going to be some problems with this, but we'll walk through those as we get through them. So line by line, we do a thing called pragma, solidity, and then pretty much we need any version. This can run on any version greater than 0.8. Greater than 0.8. So all of this means is basically what version of the compiler for the Ethereum virtual machine are we running. Next, we're going to import 2 things from OpenZeppelin. Now, obviously, what is OpenZeppelin? Actually, if you go to github.com and we go to OpenZeppelin, we can see that they have this project called OpenZeppelin Contracts, which is where we're actually going to be going to. And then if we go into the contracts folder, and then we go into token, and then you see there's an ERC721 token, and there you go. This is the actual file that we're going to be importing. So their documentation is actually out of date. We don't need to actually go to this entire length. We can actually just go to token ERC721, and then I think it's just ERC721.sol. And then we can keep counters because that's actually a really useful utility for basically, imagine, right? You mint a token, that's token 1. Well, the next time the function runs, it should mint token 2 and token 3 and token 4. And it should never be able to go backwards because once a token's minted, that's it. So we have this, and then look, we have a class here, essentially. I'm gonna call it a class. It's called a contract here, but it has a name, which we called it in the file. We called it basic contract. We're gonna call it basic contract here. And there is inheritance in Solidity. So really what happens is we're gonna say this basic contract, it's not just the bare bones contract class. It's actually going to extend the ERC721 class. Now this is important because when we do that, we now have access to a bunch of functions that ERC721 has natively. So for example, token IDs, mint, set token URI, new item ID, all of that stuff. We have access to it. So we'll make a new token called basic token, and we'll give it a ticker of basic. And now we have our first function, right? And our only function, actually. So this is a public function. Anyone should be able to call it, and it's going to return a token ID. So after this function runs, it's going to return a token ID. There are 2 things that it takes. It takes an address, which is a very specific type of string, right? It's like a actual Ethereum address. And then it seems to take this other string that's stored in memory called token URI. Now, I'm not exactly familiar with this set token URI, so I guess we're going to have to figure out what happens. The great thing is that when you're testing this, you can mess up as often as you want, and it has no consequence. And the reason we're going to be able to do that without having to spend Rinkeby money or having to spend, which is a pain to get, or having to deploy on mainnet, God forbid, you actually can just go to, this is where we would deploy and run transactions. We can actually run on this thing called the JavaScript VM. There's 2 of them. There's one in London, one in Berlin. And then there is injected Web3, which actually, I think, that will allow you actually, yes, to interface with your actual MetaMask wallet that's installed. And then there's Web3 Provider, which I've never used, so I can't really comment on that. So we're going to work with JavaScript VM. You'll see it gives us a whole bunch of accounts. I've already kind of messed with this one. So they all should have 100 Ether, and which is like a huge amount, right? This is all fake money, so it doesn't really matter. And actually, if we try to compile basic contract, let's see if this thing compiles. Undeclared identifier, let's see. Okay, so this, yeah, set token URI is not part of our function. I think we can actually do, I think we can actually get rid of this too, because we actually want to use a function called safemint. But let's see. Let's just keep trying to get this to compile. So I'm over here in this second tab, and it's going to be, let's see, we've got some remove or comment out the variable. Oh, it's an unused function parameter, so I guess because we don't use it, that's fine. Let's see. Okay. New item ID. Yeah, done. I see some issues with this function, but we're going to see what happens. We're going to click auto compile so that we don't have to click that button every single time we make a change, because that's going to get really annoying very fast. So this is how you test a very basic contract in Remix. So the first thing we're going to do is we're going to select any account. So let's just select the first one to keep things easy. We're going to click the copy button right here. You'll see the copy to clipboard. And then we're going to select our contract, which is called basic contract. And then we actually should be able to just click deploy. And did we do it? Yeah. So look at that. So now we have a contract. That was easy, wasn't it? We have a contract now. It's not like there is an owner to this contract or anything. We minted it, yes, very much. But all we did was just pay to get it out there. Let's see what happens if we pass in the address that we have selected, right? I just copied it into a ward item, and let's see if this works. Okay, so we've got a green function down here. I mean, a green status down here. And actually, this is really cool. So we're doing all of this in a virtual machine, so like none of this matters, right? It'll tell you actually what we would have paid in gas, which isn't very accurate. But what is useful is that we got our return value. See this token ID 1, right? So if we were to go to, for example, oh, well, here we can click this. We can see we got our name, we get basic token. Awesome. We go to symbol, we get basic. Token URI, this one probably won't work, but we know there's token 1. Yeah, so that's not set. So we can just actually forget about that function. That one's kind of not working for now. But if we go to balance of, and we select our address, it says we have a balance of 1. So let's click award item again, which by the way is going to cost us gas. You can see that this number changes each time we would click this button. So we click award item, we have another green check, and now if we go check the balance again, we now have a balance of 2. So what I have done, or what we have done really, is we have just given this address in this virtual machine environment, but nonetheless, 2 basic tokens, R basic tokens to be exact. This is very, 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 very basic. There is a ton of stuff you can do here. For example, if we want to make a contract payable to where basically like, oh no, you can't get a token unless you pay me or you or a developer that we're working with or whatever, okay? We have to, like, you can't call any of these functions unless you pay me a fee, like you pay us in addition to the gas. You can do that. We could have it to where, you know, we have a unique URL that shows different metadata every time a token is requested. There's an unlimited amount of things we could do. I mean, it's programming, right? The world's your oyster on this one. You just gotta, you know, make sure that you do it correctly. But this is very basic. Let's switch to something that I think people will enjoy a little bit more. So as I had mentioned before, we have OpenSea, right? OpenSea at this time is probably the place to where if you mint a ERC721 token, that's the place that you want to show it, right? That's the place that you want to sell it. That's where it's going to be sold, right? So you can mint 1 token of your special contract, 3,000 tokens of your special contract, 10,000 tokens. Who cares? Nobody cares. They'll all just appear on OpenSea because OpenSea is always reading the Ethereum network and basically syncing with your wallet and saying, hey, do you have any special tokens or anything that I should know about? And then it goes to try to get metadata and stuff like that, assuming that you used a standardized form like ERC721 or ERC whatever, okay? There is one kind of like caveat to OpenSea, and that is they make it a lot easier to work in their system because they do gasless transactions, right? That's what they claim. And it is gasless. So if I mint a token on OpenSea, or I mint an image on tokens on OpenSea, I get an OpenSea specific token, right? And then if someone buys it from me, they just pay a price. OpenSea gets a cut, they get the image, and I get paid, right? No gas actually occurred in that transaction, which is really cool. If I have an ERC721 contract, just a basic one that doesn't interface with OpenSea, it's not that simple, actually. And sometimes there can be complications. People may be having to wind up paying gas. It can kind of become a mess. So OpenSea actually has some really good docs that I found are kind of outdated. But the way to find them is you go to resources, you go to docs, you go to guides, and then you go to ERC721 tutorial. I highly, highly suggest if you are looking to make an ERC721 token and you want to have it on OpenSea, you look at this documentation. Of course, this does not translate perfectly to any other marketplaces that might exist already or will exist in the future. And in fact, ERC721 is probably not going to be the mainstay NFT token going forward. But for right now, this is what we're looking at. So you can see that what they do here is they kind of actually make this wrapper around ERC721 called tradable ERC721 token. And actually they automatically by default import the ownership utility and then actually make it to where only the creator of the contract can mint. And actually, why even talk about it? Let me just show you. So let's go back to our workspace, and I actually have a OpenSea custom ERC721. Now, this is just a very simple file. There are no tests in here, so please do not judge me. I mean, you can if you want. It's fine. Okay, so this is the entry point of the contract, right? You'll notice that I don't have ownable in here. It's actually in a different part of the contract because this one's slightly modified. But you can see, for the most part, we look exactly like this basic layout, right? There is this constructor, which basically does the same thing that the Open Zeppelin contract does, which is basically tell me what name and what token symbol you would like. But then there's two other functions that we can add here: base token URI and contract URI. And you can see here, I have a regular web address, right? Nothing special going on here, just a regular web address, all right? This URL, essentially with OpenSea, the way they do things is if they're gonna ask for metadata about a specific token, they essentially take this URL and then just add the token ID after it. So this project is twofold, right? I have to make my smart contract and deploy my smart contract, but I also have to build an API on a server somewhere, usually Firebase for me, where this URL is a real URL and will serve back a JSON response that has image URL, name, description, and some other parameters that if you read OpenSea's specific docs, they'll tell you what metadata that they're expecting so that your listing appears properly. But let's actually dive a little bit deeper into this. So ERC721, which actually, these are two custom functions I added, and this withdrawal function. I want to show you guys the most basic stuff, okay? Which again, right, as I just said moments ago, you can do so much stuff with this. You can have, all of these really, really cool extensions and, have the contract smart function as a wallet as well. It's crazy. But what we do here is you can see that there is just a whole bunch of stuff that gets imported. None of this matters. All of this stuff is basic by default. I'm gonna actually take this template right here and I'm gonna put this on GitHub. So don't worry about that. Don't worry about trying to quickly transcribe it while we're on the video. Just focus, okay? There is only one function that matters in this entire contract to us. There's a couple functions that matter when it comes to reading the metadata, but there's one really big deal, and that is a function. And this is available for any ERC721 token, or well, yes. This is the entry point into the contract. It's called mint2. It takes an address, right, which is again an Ethereum wallet string, And it is a public function, so it's visible to everybody. It's not a function that can only be called within the class. It is available for other people. They can call it. But there's this little flag called only owner. And that is actually something that you can put at the end of function definitions from Ownable. If you import this specific library, you can now use only owner. So how does only owner work? Well, let me just show you. So let's get rid of this old contract because that's no longer relevant. And let's go to, where is it? We need to find the name of our contract. I forget what it's called. Oh, I think I have to have it actually focused. Where was it? I know it just refreshed. Okay, so you can see we have custom contract, but this time, remember how last time we could just click deploy and like that was the end? Well, because somewhere in the entire like imported contract, there is an ownable function, you can actually only deploy this contract now if you give it a wallet address, right? So that means that basically whoever, in reality, what this means is that whenever I make this contract, whatever wallet address is in this field when I click deploy, whether I'm connected to mainnet, Rinkeby, this JavaScript VM, they're going to be the owner. So if I make it an address that's not mine, I'll be able to mint the contract, but someone else owns it. So that's kind of, so just make sure that you're using the right address if you intend to interface with it and you want to be the owner, right? There's a lot you can do with ownership capabilities extending beyond a single address, but we're not going to get into that. So we're going to click deploy. And you'll see we've got a new deployed contract and we've got some, some functions here. So red means that it is payable, which means that I can only interact with it if I interact and send money. We're not going to get into that. We're just going to be doing simple stuff today. Blue means I can just read. So like, for example, let's just like put in the address. Nobody's minted anything on this yet, right? We click balance of, it's going to be 0. It's a balance of 0 for everybody because if we go to total supply, you'll see the total supply is 0 because we haven't minted anything. So why would there be a supply, right? We go to name, we get custom token, we click owner, we get the address that I minted this contract with. And we do the symbol, we get custom. Now this is pretty cool. If we do this token URI, and let's just put like a random token in, you'll see that we actually get this HTTPS blah, blah, blah / token with a 1 at the end. Pretty cool, right? Token URI essentially just puts the token ID at the end of the string, and then when OpenSea tries to read it, they just go to that URL, get the metadata, and then just show metadata. OpenSea is just showing metadata to you, resolving metadata, but metadata nonetheless. Okay, we got the base token URI, which are these two strings. These are obviously two readable functions. They don't take any parameters, they just return strings. But let's get this show on the road and let's just mint something, right? So we're going to paste in an address that we own, right? And we're going to click mint to. We get a green function and we can scroll through all the logs and you can, to your heart's content, do whatever you want. We got a token ID back. If we go to balance of and check the address again, we now have a balance of 1. Look at that. So the benefit of, what did we do? Because it kind of feels like we did the same thing in two different places, right? We have this way more complicated ERC721 tradable contract, and then we had just the very basic ERC721, right? So let me just reiterate. If you want to make just an ERC721 contract, you can just use this. This is totally fine. There's nothing wrong with this at all. Obviously change up your function name to whatever is relevant for you and, change your token and contract and all that. But there may be problems if you try to use the gasless functions of OpenSea with this ERC721 function. I have not personally made a bare bones ERC721 and then expected people to be able to trade it on OpenSea. I have always used the kind of special OpenSea ERC721 tradable contract. So, like I said, I'm gonna try and put all of this on GitHub. It'll either be a zip file that's located God knows where, or if I can, I will literally copy paste every single file in the repository into a GitHub gist and post it below the video. But yeah, so let's go over the last point that I promised you I would show. This is the thing that hung me up the most. And it is how do I get this contract on the blockchain, right? Everybody has different opinions. They're like, oh, you need to install Ganache. You need to install Truffle. And then from Truffle, you can actually run the migrations, and then you can deploy. Honestly, no. Okay? Like, I am not at this galaxy-brained level to be able to do all of that. Okay? I like to keep things simple until they get so complicated that I must move into a different workflow. Mostly because I'm lazy. So what we're going to do is, this is how we would deploy to Rinkeby. I'm going to open up my MetaMask wallet. I don't have much money, so it doesn't really matter. I don't care that you guys see that. And we're going to go to Rinkeby. Okay, keep in mind, I do not have 17 ETH, okay? So please do not keep trying to, like, you know, get my private key or something. I don't have 17 ETH. This is the test network, and you can actually go to the Rinkeby faucet right here. And essentially what you can do is post in your Ethereum address when it works. This faucet almost never works. I'm sorry, but it is literally the only place to get tokens reliably, and it is typically always offline. I'm sorry. The easiest thing to do, if the faucet is offline or like whatever, all you do is you would paste in your Ethereum address, and then you would say, give me Ether. And like, for example, the day it was online, I was like, give me all the Ether, right? Usually what you have to do is you actually make a tweet with your Ethereum address pasted, and then click give me Ether. And then what it'll do is it'll check Twitter and be like, oh, okay, I found a tweet with this address. So like, I know you're a real person and not a bot, and it'll give you your ETH. If this faucet is offline like it is right now, pro tip, literally just go on Discord into like an NFT server or like a development server or whatever, or just go on Twitter and be like, can someone please transfer me 1 ETH on Rinkeby? And someone will do it. We all know how hard it is. Just a little side note. So let's just deploy this contract on Rinkeby. I mean, like, who cares? I guess let's just see how much the gas is before we do that, because I gotta be conservative with these Rinkeby tokens. But this is how you would do it. It works 100% the same way for production, for like mainnet. All you do is just, instead of having your MetaMask pointed at Rinkeby, have it pointed at the Ethereum mainnet, and it'll work exactly the same. So we've cleared out our contracts. We know we're good to go. Like, everything is happy. So what we're going to do is we're going to go to we're going to focus on our custom token.sol file. Go to this run and deploy transactions, click custom contract, make 100% sure that that is what you are doing. We're going to go to injected Web3 and make sure that everything is correct. You'll see that in our injected Web3, it already pulled in my MetaMask wallet because I've connected with this site before. Otherwise, it'll prompt you. And then what we're going to do is we're going to copy this, and then we're going to paste it in here. And then we're going to click deploy. And you'll see, actually, you see this little tag where it says Rinkeby network? Okay, so now we know for a fact that we are working through our MetaMask to mint a contract to Rinkeby. If we could deploy, it's going to bring up MetaMask because we have to do a transaction. And it says that in order for us to deploy this contract, like the real thing, right? It would cost us 0.00963 ETH. Which is very, very cheap, and that's because we're on the Rinkeby test network. If we were on mainnet, I guarantee you it would be like $200, $300. The more complicated your contract is, the larger it is, the more money it's going to cost. So there is actually a efficiency here to doing kind of like code golf and making things as simple and succinct as possible when making smart contracts. So if I clicked confirm right here, we would automatically execute a transaction, and we would just have to wait. And then the contract would be minted. But because I don't feel like spending my Rinkeby tokens, right, my Rinkeby ETH right now, I'm going to reject it. But, for example, if I wanted to take this whole contract and put it on mainnet, right, just switch this to mainnet, right, then you'll see we're on mainnet. Everything is still the same. I click deploy, and now it's going to show me this gas warning and stuff like that. We can just click confirm. And it's going to prompt us again. And as you can see, we have an unknown an unknown time. Let's see. Let's edit the suggested gas fee. Holy, I'm gonna vomit. Okay, yeah, this is clearly incorrect. Anyway, I clearly don't have enough money to mint this contract. Pro tip, if you're trying to mint a contract, try to do it at like 1 to 3 a.m. Pacific time. So figure that out wherever you may be living, because that is when gas is typically really cheap. Some days are higher than others. Today's a Friday. Don't know if that matters. But just wait. It's a game of patience. If you have to deploy a smart contract in a hurry, I'm sorry. That's all I have to say about that. But anyway, we're going to reject this because I can't afford it. But what we can do is, just, take these learnings and be able to develop in the JavaScript VM world and make sure our contract is robust and it's looking good. And then when we feel confident, deploy it to Rinkeby. It doesn't cost that much, so it's not a big deal. You just have to get the tokens first. And then once we're done there, you can test on Rinkeby actually having a contract on the blockchain. It's a big deal. It's like awesome work. Awesome. And then when you're ready for the prime time and you've got the funds to deploy the contract, that is when we can escalate this to mainnet. But all in all, that is, I hope, a understandable walkthrough and I guess, intro to Remix, the EVM, ERC721, how marketplaces work, how to make a token, and some of the things that might go into it. I'm happy to answer questions in the comments. Just let me know. Yeah, I'm really looking forward to just seeing what you guys have to say, and I will be back doing actual Web3 JavaScript stuff soon. So with that being said,